Hello and welcome to this video. In this video we will solve problem number 181 to 190, that is the 19th set of problems on polynomials and theory of equations. So without further ado, let's get started. And as always, I'll say that when I'm stating the problem, you should pause the video, and if you cannot solve the problem, only then look at the solution. Now question 181 says that solve the following system of equations for real numbers a, b, c, d, e. The system of equations are 3a is equal to b plus c plus d whole cube, 3b is equal to c plus d plus e whole cube, c is equal to d plus e plus d whole cube, d is equal to e plus a plus b whole cube. Sorry, this should be, there's a mistake, this should be 3c, this should be 3d. And 3e is equal to a plus b plus c whole cube. So it's a very straightforward problem. Without loss of generality, we can assume that a is greater than equal to b, greater than equal to c, greater than equal to d, greater than equal to e. If such is the case, then 3a, this should be greater than equal to, that's a typing mistake, 3a is greater than equal to 3e. So we assume that equality is there, a is equal to e. So now the equation becomes 3a is equal to 3a to the power cube. So essentially we are assuming a is equal to b is equal to c is equal to d is equal to e. That's what is the meaning of this. Okay. So this becomes 3a is equal to 3a whole to the power 3, and we get 3 roots, 0, 1 by 3 and minus 1 by 3. So if you look at the solution, what essentially is happening is, if a is 0, then b plus c plus d b, c, d all have to be 0, and e also has to be 0. If a is 1 by 3, then b, c, d and e will have to be 1 by 3. If a is minus 1 by 3, then remaining would be also 1 by 3, minus 1 by 3. You can approach this problem with the other inequality as well, which is a less than equal to b and so on. Now question 182 says that solve for real numbers x and y simultaneously the equations xy square is equal to 15x square plus 17xy plus 15y square and x square plus y is equal to 20x square plus 3y square. So what we do is we put y is equal to xt. So we get x cube t square is equal to 15x square plus 17x square t plus 15x square t square. And the second equation becomes x square t square is equal to 20x square plus 3x square t square. Now what we do is we multiply the second equations by t. So it becomes x cube t cube 20x square t plus 3x square t cube. So we subtract, we get 3x square into t minus 5 into t square plus 1 is equal to 0. Now once we have this, we can say that x is equal to 0 or t is equal to 5 or xy is equal to 19 and 95. There is something wrong here. Let me check. So 15x square would be not changed. This will become x square t, that is minus 3, and this would remain same. 15 and this would remain same. Left side will be equal. You perform the calculation. I think it is wrong calculation, but anyway you get the general idea that how it is done. It's not wrong calculation, actually it is some typing mistake. You can figure this out. I need pen and paper to do that. Now, question number 183 says that solve the system of equations in integers 3x square minus 3xy plus y square is equal to 7. 2x square minus 3xy plus 2y square is equal to 14. So we subtract, we get y square minus x square is equal to 7. That is y minus x into y plus x is equal to 7. Now there will be 4 possibilities. Y minus x is equal to 1 and y plus x is equal to 7. And y is equal to 4 and x is equal to 3. That would be the result of this. The second solution would be y minus x is equal to 7 and y plus x is equal to 1, which gives y is equal to 3 and minus 4. So this would give, okay, y minus x is equal to 7 and y plus x is equal to 1. So we have what values of y? Y can be 4. Sorry, there is a mistake. Not a mistake. Over here y is 4 and x is equal to 3. Okay, 4 and 3. So this becomes 1 and this becomes 7. And if this is 7 and this is 1, then we add y is equal to 4. 7 and 1, 8, 4. 2y, y is equal to 4. And then x becomes, wait. So there are 4 possibilities. Over here y minus x is equal to 1, y plus x is equal to 7. So y is equal to 4 and x is equal to 3. So this becomes 1, this becomes 7. Over here y minus x is equal to 7 and y plus x is equal to 1. So the solution should be okay, 3 and minus 4. So if you put 3 and minus 4, then y plus x becomes minus 1, okay, which is not true. And y minus x becomes, so this is y is equal to 3 and x is equal to minus 4. And this becomes minus 7. So minus 7 into minus 1 would be 7, but y plus x cannot be 1 anymore. So which does not satisfy the given equations. Okay. So y minus x becomes minus 1 and y plus x becomes minus 7. So this gives us y is equal to minus 4, x is equal to minus 3, and y minus x is equal to minus 7, x is equal to minus 1. Y plus x is equal to minus 1, which gives y is equal to minus 4, x is equal to 3, which again does not satisfy the given equations. Question 184 says that in the sequence a1, a2, a3 up to an, the sum of any 3 consecutive terms is 40, if the third term is 10 and the 8th term is 8, find the 2013th term. So it is given that sum of any 3 terms is 40. So we can say that a1 plus a2 plus a3 is equal to 40, a2 plus a3 plus a4 is equal to 40. Now we subtract, we get a1 is equal to a4. We can say that ai plus 1 is equal to ai plus 4. And similarly, we can compute that a3i is equal to a3i plus 3. So a 2013 would be equal to a3, which is given as 10. Question number 185 says that a sequence has the first term 2007, after which every term is the sum of squares of the digits of the preceding terms. Find the sum of this sequence up to 2013 terms. Now you see our first term is 2007. The second term would be sum of square of digits. So 7 square is 49 and 2 square is 4. 49 plus 4 is 53. Similarly, 5 square plus 3 square would be 34. And so on. We continue. What we are interested in, this 89. Okay, why we are interested, you will see. So we continue again and we find 89 repeats at 15th position. So once 89 has come, it will again repeat the sequence of 8 numbers. So T8 through T15 will continue repeating. Okay. Now, not really. So what will happen is T7 to T14 is repeating, 89 to 58. And then again T15 to 22. So the sum of first 7 terms is 2322. Okay. Now this will have a repetition of next 8 terms. Number of such repetition would be 2013 minus 7 by 8, which is 250 plus 6 by 8, 2006. Yeah, that is correct. Now sum of these 8 terms is 411 and sum of first 6 terms is 264. So the required sum is 2322 plus 411 into 250, because this 250 is there, plus 264. Okay, so that would be 105,336. Now we move to question 186. Find the finite sequence of 16 numbers such that it reads same from left to right as from right to left. The sum of any 7 consecutive terms is -1 and the sum of any 11 consecutive terms is +1. So we take the sequence to be A1, A2 and up to A16. Since given that sum of any 7 terms is -1, we write A1 plus A2 up to A7 is equal to -1, A2 through A8 to be -1 and so on. And the last would be A10 through A16 as -1. Also given that sum of any 11 consecutive terms is 1. So A1 through A11 is 1. And we continue, we get A6 through A16 as 1. You see there are 6 equations here and there are 10 equations here. Okay. So overall 16 equations and there are 16 unknowns. So it's a simple matter of solving. For example, if you observe the first equation and the second equation, that is this one, if you subtract, you will get A2 will get cancelled, up to A7 will be cancelled, you will get A1 minus A8. So A1 would be equal to A8. Okay. So you continue this and you will find that A1 is equal to A16, A2 is equal to A15 and so on. And you solve and you'll get the numbers as 5, 5, minus 13, 5, 5, 5, minus 13, 5, 5 and so on. So it's a simple arithmetic problem. Question 187 says that a two-pan balance is inaccurate since its balance arms are of different lengths and its pan are of different weights. 3 objects of different weights A, B and C are each weighed separately. When they are placed on the left pan, they are balanced by weights A1, B1 and C1 respectively. When A and B are placed in the right pan, they are balanced by A2 and B2 respectively. Determine the true weights of C in terms of A1, B1, C1, A2 and B2. So because the inaccuracy, if there is X weight in the left pan and Y in the right pan, there will be 2 constants M and N such that Y is equal to Mx plus N. Okay. Once we have this relation established, what will happen is that A2 will become MA1 plus N and B2 would be MB1 plus N. So N will become B2 minus A2 by B1 minus A1 and N will become A2 B1 minus A1 B2 by B1 A1. So from this we figured out M and N. And then C2 would be MC1 plus N. Now we substitute the values of M and N to get the value of C2 in the required fashion. Question 188 says that if A and B are 2 of the roots of x to the power 4 plus x cube minus 1 is equal to 0, prove that AB is the root of x to the power 6 plus x to the power 4 plus x cube minus x square minus 1 is equal to 0. So it's a simple matter of weight as term relation. So we take A, B, C, D as root. Then from weight as relationship, we have A plus B plus C plus D is equal to -1. That is coefficient of x cube by coefficient of x4 and negative of that. AB plus BC plus CD plus AC plus AD plus BD will be equal to 0 because the coefficient of x square is 0. ABC plus ABD plus ACD plus BCD will also be 0 because coefficient of x is 0. And ABCD would be minus 1. Now from this last relationship, you can say that AB is equal to minus 1 by CD. And from the first relationship, you can say that C plus D is equal to minus 1 minus A minus B. Now we look at this relationship, that is third. We can say that second relation. AB plus A plus B into C plus D plus CD is equal to 0. So now we substitute the values of AB, not AB, CD and C plus D. So we get AB plus A plus B into minus 1 minus A minus B minus 1 by AB is equal to 0. We let A plus B is equal to M and AB is equal to N. So the equation becomes N plus M into minus 1 minus M minus 1 by N is equal to 0. We are also given that ABC plus ABD plus ACD plus BCD is equal to 0. Not given, this is what weightage relationship is. So from this, what we can write it as minus N into, not minus N, N into minus 1 minus M minus N by M is equal to 0. So from this one, we can figure out N as minus M square by M square plus 1. And thus, we will have the relationship, if we put it in here, we will have the relationship n to the power 6 plus n to the power 4 plus n cube minus n square minus 1. We don't care about denominator. This is 0. So numerator is 0 and therefore AB is the root of, now we look again, what is our AB? AB is minus 1 by CD and we have let AB is equal to N. So N, this equation is 0 and N is nothing but AB. So AB is the root of x to the power 6 plus x to the power 4 plus x cube minus x square minus 1 is equal to 0. Question 189 says that if Px, Qx, Rx and Sx are all polynomials such that Px to the power 5 plus xq x to the power 5 plus x square r x to the power 5 is equal to x4 plus x cube plus x square plus x plus 1 Sx, prove that x minus 1 is a factor of Px. So we consider three roots of unity. These are fifth roots of unity such that L to the power 5, M to the power 5, N to the power 5 would be all 1. So what happens is P of 1 plus LQ1 plus L square R1 is equal to L to the power 5 minus 1 by L minus 1 SL. And similarly for M and N. Okay. So now what we can do is, there's a mistake, typing mistake here. This should be N. Let me observe it. NQ1. No, this is not that. So from these two equations, we have MQ1 plus M square R1 is equal to NQ1 plus N square R1, which implies that Q1 is equal to minus L plus M R1. So these are simple calculations. Once you have established the relationships, these are simple calculations. And by symmetry, we can say that Q of 1 is equal to minus L plus N into R1. Now, since L is not equal to N, it follows that Q1 is equal to R1 is equal to 0. And then we have P1 plus LQ1 plus L square R1 is equal to 0. And that's why x minus 1 is a factor of Px as asked for. Now we come to the last problem of the set. If x to the power 5 minus x cube plus x is equal to a, prove that x to the power 6 greater than or equal to 2a minus 1. So in this, what we do is we simply substitute the value of a and we factorize. Upon factorization, we get x square minus 2x plus 1 into x power 4 minus x square plus 1. So this is x minus 1 whole square, and this is nothing but, if you look at this, this is a by x. So this is greater than 0. And so if you ask me why this x to the power 4 minus x square plus 1 is greater than 0. So what we are looking at is a by x. Now, if you look at the value of x, if you consider x positive. So between 0 and 1, okay, between 0 and 1, x would dominate, okay. So it will become positive. This and this positive, and this negative term will be less than x. So between 0 and 1, this is positive. Now if it is greater than 1, then x power 5 will dominate x cube, and again a will be positive. Now we look at negative numbers. Okay, between 0 and minus 1, this x to the power 5 would not dominate. This term will dominate like negative numbers, like positive numbers. This term will dominate between minus 0 and minus 1. So this entire expression is negative. So a is negative, but a by x is negative upon negative, so positive. And similarly for numbers greater than minus 1, a would be negative, so negative upon negative would be positive. And that is why x to the power 4 minus x square plus 1 is always positive. So with this, we come to the end of 19th set of problems, and I hope that you are enjoying this series of videos. And if you are enjoying, then please subscribe to the channel if you are not already subscribed. Do not forget to like the video and share it. If you have questions or you want videos on certain topic, make use of comment box. The reason why I ask for all this is because that's how YouTube propagates the videos more and more. And if you share it elsewhere in social media or your own blogs or elsewhere, Reddit or something, then the reach of video increases. And that's the whole idea, to help as many people as we can. So thanks a lot for watching. Enjoy.